Hello. I hope you guys are doing great. Our today's topic is latent heat of vaporization. Previously in one of our previous videos we discussed about latent heat of fusion. Do check it out as well. Link is at the top, as well as in the description box. So coming back to our video, which is latent heat of vaporization. Latent means hidden, and vaporization means conversion of substance from liquid into vapors. Latent heat of vaporization is defined as the quantity of heat that changes the unit mass of liquid completely into gas at its boiling point, without any change in its temperature, is called latent heat of vaporization. So its formula will be HV equals delta QV over M, which is quantity of heat required to change unit mass. When heat is given to a liquid, the liquid starts absorbing the heat, but it will not change its state. Up to a specific limit it will only absorb heat, but after some time it will stop absorbing heat. Yet this time it will change its state. This process is called boiling. We will elaborate this process with this experiment. Initial steps of this experiment is quite similar to the experiment performed for latent heat of fusion. For this experiment we take ice cube, beaker, thermometer, stirrer, a stand with a clamp, wire gauze, tripod stand, Bunsen burner. Take some ice cubes in a beaker. Place the beaker on wire gauze kept it over tripod stand, and insert a stirrer into the beaker. Take a thermometer and suspend it with the help of the clamp stand, so that its bulb remains in the middle of the ice cubes. Heat the ice cubes in a moderate temperature using a Bunsen burner, and stir continuously to keep a moderate temperature throughout. Note the temperature when the ice changes into water. Continue heating the water until it reaches its boiling point. Note all these observations. Now we will explain these observations using a graph. Mass of water will be m. Time when water absorbs the heat. On moving from 0 to 100 degrees Celsius it will be T0. While the time at which water changes its state at 100 degrees Celsius will be TV. V here is basically for vaporization. T0 will be time 3 minus time 2. The resulting portion will be this blue line, where the water is just absorbing heat. TV will be T4 minus T3. So the resulting portion will be this red line, which is the time when water only changes its state. There will be no change in the temperature. So after observing all our experiment, these are our observations. Mass of water will be m. Time when water is heated from 0 to 100 it will be T0. Similarly, when water is heated at 100 degrees it will be TV. Specific heat capacity of water is C, which is 4200 joules per kilograms. T0 was T3 minus T2, which is 4.6 minutes. TV will be T4 minus T3, which is 24.4 minutes. Change in temperature of water will be 100 degrees Celsius, which equals 100 Kelvin. Because 1 Kelvin equals 1 degree Celsius. Heat required to heat water from 0 to 100 degrees Celsius is delta Q. As you know, delta Q equals mc delta T. Here m is mass, C is specific heat capacity, while T is change in temperature. Delta means change. After putting the values, mass of ice is m. C is 4200 joules per kilograms per Kelvin. Delta T is 100 Kelvin. Then, m into 4.2 into 10 raised to power 5 joules per kg will equals delta Q. Before moving ahead we will go through this example. Suppose price of 10 pencils is $20. As you have studied in previous grades, to find the price of one we will divide 20 by 10, which results in $2, which is actually the price of one pencil. Similarly, to find the price of 5, we will simply multiply 5 with the price of 1, which is $2. So the answer will be $10. Now you guys are definitely thinking that while we solve this example, the answer to this question is that when amount of heat absorbed to change 1 Kelvin temperature in time T0 is delta Q over T0. Similarly, amount of heat absorbed in time TV will be delta Q over T0 into TV. As we studied earlier, that to find the price of one we use division, and to find price of more than one we use multiplication. Let's say this is price of 1, and we want to find the heat absorbed for TV. We will simply multiply it with this 1. This is just for a learning point of view. Now we will arrange it. As we studied earlier, delta Q equals M into HV. It will not be wrong if we would write QV instead of Q. Similarly, we put the values here. M and M cancels on both sides. After putting the values of TV and T0, our resulting answer will be 2.23 into 10 raised to power 6 joules per kilograms, which is the value of latent heat of vaporization of water. Now I know you guys are quite fed up, but don't worry, we will now wrap up our lecture. As we studied in our previous video, at this stage ice only absorbs heat. Its temperature will change from -30 to 0 degrees. Similarly, at this stage temperature will not change. Only state of ice will change to water. This process is called latent heat of fusion. At this stage water will again absorb heat, and its temperature will heat from 0 to 100 degrees. At 100 degrees it again stops absorbing heat. At this stage it will only change its state and there will be no change in its temperature. This is called latent heat of vaporization. Because when we inserted thermometer in the beaker during our experiment, there was no deflection on thermometer, so this process is hidden and is latent heat of vaporization. So that was our today's lecture. I hope you understand. If you have any difficulty in this derivation, so please comment down below. Link for latent heat of fusion is at the top, as well as in the description box. Click here to subscribe our channel. Press the bell icon, so you will never miss any of our updates. Till then, take care, and bye.